In this video we are going to talk about hovering control for a quadrupter using a VREP as a simulator, and was used ROS to teleoperate the motion of the UAV. Okay, so you can see here the simulator VREP, formerly VREP, nowadays called CoppeliamSim. So this is a environment, and we have our UAV. This is a quadcopter. So the goal of this video is to control using a communication with ROS to send commands to put in a specific position of the robot. So let me show you. I'm going to start my simulation, and I'm going to send commands from the teleoperate node using ROS. So I have to publish in this node. This is called, let me see, linear position. Okay, linear position and Z axis. I want to send 4 as a data. Okay, you can see how the robot receive the data and go up. Now I can send this position like this, and now I want to send commands for a X direction. Okay, this is a C and this is an X. Oh, okay, this is okay. So now let me show you how this controller was made, or was done, using this some information about that. First of all, we have to know about the cinematics and dynamics of the robot. So information. Okay. To control a quadrupter UAV, is necessary to know some theory about the rigid body. In this case, the quadrupter is modeled as a rigid body. Now we have to take into account that the rigid body have a transformation and a position and orientation. This is called a cinematic for a robot. So when we applied a specific angle to our rigid body on our joint, this have to change our position and orientation. So now for a quadrupter in 3D environment, we have to take so this one, we have to know the dynamic of the robot. Dynamic of the robot is modeled using Newton equations. You know, this is a equation m by mass by acceleration equal to the force of the robot. Okay, you know, this affect the position and stability of a robot. With these two algorithms, an equation of the cinematic and dynamic of the robot, we can modelize our controller. Now, controller is for a 3D environment, and we have to do this control law for control altitude and position of the robot. So our variable to control are the position and orientation, like yaw pitch roll on X, Y, and accelerations. So this is really complicated when we want to control, because this is a non-linear equation, but we can apply a linearization on a specific point. So in this case, the controller can be made on or designed using a PID controller. So for a simulation VREP, we have our code. This was used Lua language. So in this shortcut, we can see how the communication is between the simulation, the environment, and ROS framework. We have here so let me see here we have the subscriber. That is the code that sends commands to a ROS framework. The communication which ROS have to be done using a plugin to send commands to ROS. Now, when we have these commands, we can control remotely the position of the robot. But the control have to be done using a short transformations, like I showed in the 3 articles before. So we have to control 4 actuators to stabilize the position of the quadrocopter.